Extended. Unmute and check the audio. And what I want to hear is echoes. Hang on a second. And, hello? There we go. All right, so good. So the room mics are working. And then I don't know who else was sitting here before we changed sessions, but we want to have your speakers over here so I can record you over there.
All right, perfect.
And, go ahead, I'm sorry.
One more colleague
Yeah.
is remote. I'm going to ping him and.
Oh, yeah, and as long as they're on time, they could just take over screen sharing and start speaking.
Perfect.
And they'll show up right there and the whole room will hear, and the world will be good.
Yeah,
And by the way,
Omar,
Omar, it's a pleasure. I remember your name from email, so it's a pleasure to meet you.
Likewise.
Yeah, I've been working with Ray for quite a few years, and I don't know how long you've been around, but during the pandemic, actually, we had an enablement session with Anyscale, and it was a great session. We recorded that as well. And it got a lot of response internally. So yeah, so I'm really glad you're here. Thank you. Thank you for going through this.
It's my pleasure. And I'm assuming that this is an opportunity for those who are not familiar with Ray to introduce them to it.
Oh, yeah, absolutely. Yeah. No worries. So we have 2 more minutes. I think we're set up. I just want to make sure I'm not forgetting anything. So,
Super.
And let's see.
If it's okay, I'll stop sharing for a little bit.
Okay, yeah, that makes sense. Yeah.
Sit here.
I mean, I sit in one of them. They're asking us to sit here. Yeah, so you could go there. I think once the for J guy.
Yeah, so
Here, guys,
just,
I can move.
Yeah.
Is sitting there okay?
Please, yeah.
Is there okay, or should I sit here?
It doesn't matter as long as you're
Right on.
next to Omar.
Cool.
Yeah, so the way we do these videos, just FYI, is of course we're recording with time, but then if I could get a copy of your deck, and then I combine that with this video, it makes a real professional looking video. So,
Yeah, we could definitely share that.
that's why we have all this stuff. And the video, it's up to you whether you want to share it on your social media, but we definitely share it internally here.
Yeah.
To a couple of thousand people.
That's fantastic.
Yeah, that's kind of the whole point.
Awesome.
And then I don't know, I should have chatted, I'm sorry, the gentleman, Ravi, about doing a interview for our sales team.
Yeah.
So and forgive me because we had a little trouble scheduling and I didn't get everyone's names.
Yeah, I'm Hank.
You're Hank.
Yes.
Hank, you might be the one to interview. Did anyone talk to you about that?
No, would that be today?
Yeah, that
No.
would be today. So no one talked to you about it.
Yeah.
So it's my request. And
Okay.
don't feel obliged. But what we do is we have an internal only video series. What I do is set up a 2-camera interview. With you and me. And we talk for maybe 20 minutes.
Sure.
And the issues are, you are speaking directly to field sales.
Okay.
And the question is, what does field sales need to know to recommend Anyscale as a solution? So it's like, who are you? What do you do? What's your differentiation? What are your key use cases? And what incentives do you have for field sales, like if you're in an ACE program or a strategic collaboration agreement or something like that?
Yeah.
If you can do it, then please do.
I want to take you up on it, but I feel like I need some time to prepare. And
I'm an ACE program and all that I can talk about that.
So maybe
it's an interview.
Uh-huh.
Are you familiar with this?
Yeah, I'm just telling you about the possibility of an interview. You don't feel obliged.
Yeah.
It's like 100%.
Yeah, which is also
credit, but I can't tell you how valuable it is.
Yeah.
It's actually more invaluable than even. But
I think Chad was planning to
Chad?
for the next time.
Okay.
Wednesday, if we have anything recorded.
Okay, we could do it next. I think we have an event on April 11th, so maybe not with Anyscale, but if you wanted to do the recording, then we could do that.
Yeah. No, that
So
sounds like something we should do.
I'm gonna rally everyone back in.
Cool.
Yeah. All right, let's get started.
Are you gonna do it?
I'm not prepped to do an interview.
Hey, Robbie.
Yeah.
Got it next. Next. Chad next. Let's talk. For April 11th? No, April 11th, we are not here. We are not.
Cool.
There's no echo, right? Because I logged in as well just to see the slide.
Screen.
So it's pretty casual.
All right. Guhan, if it's not too much trouble, do you mind sitting somewhere else? Because I want to get the speakers together there. Feel free to take my seat.
I know he said here. Okay.
All right, so there's a good chance, let's see, we're not muted, even though it says mute up there. There's a good chance that we're working now with the room mics. So when there are questions and when you're speaking, it'll be coming from this high-tech arrangement, which took us all morning to figure out. But I want to welcome Anyscale. Thank you so much for being here today and doing what we've got. So our partnership with Anyscale goes back at least 3 years. I'm almost thinking 4. Don't quite know, but I've worked with Anyscale for that entire period. So with Art, of course, really happy to welcome you here today. So Omar, please take it over.
Thank you, everyone. Always happy to work with AWS, and for me personally to be back here. I am a former solution architect at AWS. Super excited to be in the team again, so to speak. So we understand, you're all SAs. The way we plan the agenda for today, it's going to be technical. We hope to walk you through a technical primer on what Array is. It's an open source library which Anyscale commercializes, and then show you the Anyscale platform. But we thought we'd take some time to give you some context to show you what Anyscale is. So we'll start a little bit non-technical before diving in. And so to kick us off, it's going to be my colleague, Hank. He'll speak for 10 minutes. I'll introduce Ray, and then we'll talk to you about Anyscale and the platform. Do not hesitate to interrupt with questions. It's designed to be interactive, so feel free to stop me as we go through this.
Cool. Thanks. Yeah, good to meet all of you. I'm Hank. I'm one of the sales leaders at Anyscale, based right here in New York. Quick disclaimer, I'm definitely not a solutions architect, so I'm going to spend about 10 minutes talking and then pass it over to Omar, but we want this to be interactive, so please interrupt us as we go along, ask questions, and we take it from there. So this picture on the right is taken at the RISE lab at UC Berkeley, and the guy right here is Jan Stoica. Jan is the co-creator of Spark. He's the executive chairman of Databricks, and he runs labs at Berkeley. And within his RISE lab, our co-founders, Robert and Philip, were doing AI research. And they were trying to build AI algorithms, and they found that they were spending all of their time figuring out how to scale up the underlying infrastructure. And so they realized this was a huge problem for them to solve, and they created Ray. Ray at its core is a distributed computing framework. It's all Python, very simple code. And essentially, it makes it so that you can build a Python application on your laptop, distribute it out into the cloud heterogeneously across CPUs and GPUs in the most efficient way possible. And so Ray was officially released in May of 2017. Lot of traction, one of the fastest growing open source products ever. And Anyscale was created in 2019 as kind of the commercial offering. We're backed by Andreessen Horowitz, Edition, Intel Capital, among others. So Ray, saw steady growth since it was created, but really in the last year and a half, as AI has kind of taken off, Ray has 10x'd in growth. There are over 1 million clusters launched per month globally using Ray. We have over 1,000 plus contributors to our open source. And you'll see here from the list of customers, there's a really wide range. We have, anyone from Runway, who's kind of revolutionizing the AI video generation market, kind of a smaller startup, all the way to companies like Amazon, who actually switched some workloads from Spark to Ray and found savings of over $100 million. So really, what these companies have in common is a insatiable desire for compute, and Anyscale helps get compute into more people's hands in a very efficient way. We'll dive into obviously more financial stories and use cases, but I just kind of wanted to set the stage. So I think you can break down our value into 3 main categories. So the first is scale. I think we all know that one of the most important parts of building powerful AI models is that the compute continues to grow, and you need to have a really scalable framework under the hood. And once companies get a taste for AI, the desire for more AI just compounds exponentially. And so I won't go through all these stories, but I think the Ant Group is a cool story. Over 1.5 million CPU cores deployed for online model serving. The most ambitious Python workloads in the world, such as training ChatGPT, are done with Ray. So over a 300 billion plus parameter foundation model that is trained using Ray. The second is cost efficiency. So most companies, as you all probably know better than I do not get great utilization on their resources. And so one of the things that we help them to do is get really strong utilization and also run workloads more efficiently so that it actually runs faster. So I shared the Amazon story. eBay, we had a 4x improvement in GPU utilization. Pinterest was able to lower costs by 30x from switching from Spark to Ray. And then the last piece is developer productivity. So as I mentioned, it's all Python. It's super simple. Really strong use cases in autonomous driving. Zoox was able to reduce lines of code by 100x, which is very significant. Canva, one of our strongest Anyscale customers, is able to iterate 12x faster. So it's partially skill, partially cost efficiency, and developer productivity, which we really think about as time to market and de-risking these massive budgets that are being poured into AI. Any questions so far? Cool. So I won't spend too much time on this slide, but I think it's helpful. It's a concept we talk about a lot, is this thing called a AI complexity wall for platform builders. And really what you see here is the fragmentation that exists in different subsets of kind of the AI ML space. So different workflows for data processing that are mostly CPU based. Then your ML and data science teams are using different products to actually train models. And then GenAI, with new models being released every day, creates a whole other category. And none of these categories are really working cohesively together. And when people are building and developing their own AI strategy, you want to actually, benefit from having the same framework and resources, pre-process data, feed it into the models so that they can be trained and served, and also be able to use open source LLMs. And so, with Anyscale, one of the most kind of relevant people for us to talk to are platform leaders, because suddenly they can control all of this sprawl and fragmentation and have a single platform for the full AI lifecycle. So what are the costs of the complexity wall? Wasted compute, 6% of companies see utilization above 85%. Skyrocketing costs, don't really need to explain that one. AI is becoming the biggest budget item, especially in the financial world. And then slow to get to production. So a lot of people have these big aspirations for what to do with AI. Maybe they rolled out some stuff with OpenAI in the early days, and now they're trying to really hone in their own strategy. And only 10% of orgs are able to actually take that to production, with over 45% working pilots. I think Omar will dive deeper into this, but I think it's helpful to kind of share this spectrum of data frameworks to highlight really the differentiation that Ray brings to the market. So, what Spark did for analytics and structured data, Ray does for AI and Python-based workloads and machine learning. And so just to go to the next slide, you'll see here a lot of the most innovative financial institutions in the world are building their AI strategies with Ray. The way they're using Ray is really through 3 layers. So underlying compute, so we can connect, most, I would say, 90% of our companies that we work with, probably higher, are using Anyscale to manage cloud resources within, their own CSP. So we connect directly to their AWS environment. We can also offer a hybrid strategy with whatever they're doing on-prem. Ray Core comes and sits on top, and it's a low-level distributed compute framework. And then we have a suite of Python libraries that we built on top. So we have Ray Data for unstructured data pre-processing, Ray Train for multi-GPU training, Ray Tune, Ray Serve for actually serving out these models into production, whether it's batch or real time. And so, yeah, I think the logos kind of speak for themselves. And within these organizations, we're often speaking to the most innovative teams, like the AI units that are just being created and trying to build their strategy. Yeah.
Question, maybe you'll get to it. Are these customers Anyscale customers, Ray customers, both?
It's a subset.
Okay.
Yeah.
And then can you just talk a little bit about if you all didn't exist, what are the struggles or the process that they go through to achieve the same result?
Yeah. Do you want to take that one?
Yeah. You can think of Anyscale is to Ray as EKS is to Kubernetes. So the struggles customers would face operating in the Ray environment would be the same kind of struggles they have managing their own Kubernetes clusters. So it's a managed service to take that undifferentiated heavy lifting away that becomes really easy. And I'll dive a little bit into that to show some of actually Stephen is going to go into the details of some of those complexities and how we work around them.
Great, thanks.
Cool. So Anyscale is the managed offering. It's the best place to run Ray. I think it will make more sense when we go into the demo, but we can break down the value into these kind of like 5 categories here. So the first is a really nice developer experience with an integrated IDE, dependency management, all the things you would expect. A suite of production services built to ensure that production workloads are running with high availability, that you have things like canary upgrades, when people are running really complex, and many workloads, being able to actually prioritize what is getting the compute first. And then down here is Ray Turbo. So Ray Turbo is our hyper optimized version of Ray, more scalable, it's more reliable, it's faster. And compute governance, so we can help people kind of dynamically create and share quotas across different teams so that they can control the underlying spend. And then unified compute management. This is a really important one. So unified compute management is Anyscale's differentiated ability to access Spot whenever it's available, to kind of intelligently look at all the different resources and pick the ones that are cheapest and best for the job to be able to run workloads across CPUs and GPUs in the most efficient way possible. So that's a really important piece as well that we'll show you guys live today. So just to focus a little bit on Ray Turbo, some of the metrics that we talk about. So 60% lower costs with enhanced infrastructure and spot support that I mentioned before, the ability to run the same workloads with about half as many nodes, pre-processing data about 4.5 times faster, 20 times faster model loading, faster upscaling speed. So a lot of different components that we're really focusing on to make sure that people that are using Anyscale get better performance, better reliability, and the ability to, in turn, consume more compute. So some success stories in finance that I think are interesting was just in London. The Man Group they had a bunch of workloads that were kind of running on Spark and Dask, and they switched to Ray and Anyscale and saw 5 times faster performance, like immediately. Bridgewater, which Matt and I were just talking about yesterday, is training, tuning, and running 50,000 models with Ray. With Ray today, they are able to scale to somewhere between 2,000 and 4,000 nodes. Obviously, for an organization like this, the ability to run their backtesting jobs faster creates like an immense amount of value. With Anyscale today, they can scale to about 15,000 nodes, and we're talking about working with them to eventually reach what they want to do, which is 100,000 nodes. Can't promise when that's going to come, but significantly better performance and scalability with Anyscale. The last piece is, why we think there's such a strong better together story here. There are so many organizations that are building on AWS and using Ray. Anyscale is a great mechanism to get, the ability for more people on the team, whether it's, researchers, developers, machine learning engineers, to be able to efficiently consume the compute that they're getting from you guys. And obviously, the more efficiently they do that, the more they're going to come back wanting more and be able to further invest and develop their AI strategies. Thanks.
Fantastic. So that's how we talk to customers about Anyscale and Ray. We're going to do 3 things next. I'll start and then get technical. So I'll give you a technical primer about Ray, what it actually is. I'll be doing it from both the developer perspective and then the architecture perspective. That's one. Steven is going to show you the Anyscale platform, which is a managed service for Ray. And then the third thing we're going to do is we're going to talk about how Anyscale works with AWS and how our joint customers are using it. So 3 steps. Let's start with Ray. What is it actually from a developer's perspective? It's a Python library. So a developer imports Ray, and the promise is they can go from there to doing parallel computation. And the library itself is designed to interact with the cloud, to interact with AWS. The core part of the library has some fundamental concepts that you use to do parallel computing. That's the core library. And then on top of that, there's a suite of libraries that are designed for different parts of the life cycle of AI and machine learning development. So we show 4 libraries here. There are actually 5. And I'll talk about those first. But I'll start with the core just to drive that in. And I think the best way to do it is with examples. I'll be walking through some code. The example I'm going to show you is a Monte Carlo simulation, quite common in insurance industry, for example, for value at risk. I'm going to take a trivial example. I'm going to do a Monte Carlo simulation to estimate the value of pi. Right? It is March, maybe a little late for Pi Day, but I thought that would be a good idea. So let's dive in. And let me start by showing you this code. All right. And maybe as always, demigods are not entirely in my favor, but we'll fix that soon enough. There we go. All right, let's do it this way. All right. So I'm going to walk you through a notebook that actually uses Ray to go from a single machine to a parallel computation. And here's how it works. So Monte Carlo simulations basically run some calculations many times, and then from the aggregate of them, it concludes things. So we're going to do a Monte Carlo simulation where we're going to calculate pi. It turns out that if the ratio of a circle's area and a square's area has pi in them. And so what we're going to do is we're going to do a lot of random tasks where we find points in a square, count how many of them are inside a circle, and then use that ratio to calculate pi. It's a very simple calculation. And this diagram shows exactly that. So green is inside, red is outside. The ratio of green to all the points turns out to be pi over 4. So if you multiply that by 4, we have an estimate of pi. And the code for that starts with just importing some libraries you need, still doing this in a singular fashion. And then here's a function that is written in Python that takes a number of trials to try the number of points to find, plot them, and return back how many are inside. So it's very simple code. Start with 0 points inside, pick 2 random numbers between -1 and 1, figure out what's inside the circle, and if it's inside, add a number 1. Very simple, straightforward code. The second function runs that first function, simulate, gets the number of inside points, does the math, multiplies that by 4, the ratio by 4, and it has an estimate. And the way I wrote this function, it not only estimates pi, but gives us idea what the error is. So those are 2 functions. That's how a developer on a simplistic level would work with code on one machine. So let me run those, and let's give it a try. I'm going to run this twice and see what happens. First with 100 points, and then again with 1,000 points, and see what I get. So it turns out the first estimate with 100 points is 2.8. Not so cool, but it starts getting better when we get to 1,000 points. And we see that the more points we simulate, the closer we get to the actual value of pi. So we have an algorithm. We know it works. We just need a lot of scale for it to be meaningful and to train. So what happens if we try to do that with, let's say, 100 million points? And it turns out if I do that, it's going to take a lot more time than with 100 or 1,000. In fact, this is going to run for 1.5 minutes. In the real world, this could be runs that takes weeks, if not months. And so we want to parallelize them. And here's how we're going to do it. Like I said, Ray is a library. You import Ray, and you initialize the Ray cluster. So 2 lines of code there. And then I just copied the function simulate, and I called it parallel instead. Now here's where Ray comes in. All I need to do is decorate it with a decorator called Ray remote. So now it's a remote function that's going to run remotely in a cluster. And then what I'm going to do is I will call this function remotely, parallel remotely, instead of running it once with a certain number of workers. And I will get the results back from the cluster using the function rayGet and return the 4 times the number of inside and the total number of workers. So as you can see, I just added a few lines of code. And the hope is I can go from what was 1 minute, over a minute, to less than that by distributing the code over a certain number of workers. So that's the common workflow. Let's see if this works. I actually had to write some code as we go because I lost some of what I prepared. But so far, so good. Let me see if I can get this to work with 4 workers, and I'll do 25 million trials each for a total of 100 million, which is I tried before. Ooh, it works. And actually, stop it because I'll need the value of pi, and I'll print pi. All right. Run that again. And with any luck, this should run in less than a minute. So there it is, some code to parallelize. And in the background, what's going to happen is Ray's going to distribute these functions, create and launch 4 workers across a Ray cluster, run things in parallel, allow me to aggregate the code, all with 2 functions, remote and get information back. And this is a promise of Ray. This is why developers love that. And you can begin to see if I want to run a heavy computation across 150,000 CPUs, all I have to do is specify 150,000 workers, and Ray will take care of all of that. And as you can see here, there's a result. It didn't quite tell me how, but I hope that that's less than a minute, but you get the picture, right? That's the promise of Ray. Any questions? All right, looks like I nailed it. All right, so let's go back and take a look at some of the theory again, and what you're saying about Ray. I spoke about how Ray Core is that fundamental library that has these constructs that make it really easy for developers to go out and do that. And then on top of that, we build the other libraries. And what the other libraries do is they have these abstractions that, again, developers love. So for example, if you want to deal with a large data set that's many terabytes, even petabytes sitting on S3, we have an abstraction that says read Parquet, and then you have this virtual data set that's sitting in the S3, and it optimizes the read into those GPUs for machine learning training. That's Ray data. We have Ray Train that parallelizes and does distributed parallelization using frameworks like PyTorch and Lightning and so on. We have Ray Tune, which makes it a pleasure to do hyperparameter optimization. And then Ray Serve, which makes it easy to serve these models across multiple GPUs, all built on top of the powerful constructs of Ray Core. Then we have the 5th library called RLib. And developers use these, they download, right? They install it and they work with it. And a lot of the names that you saw earlier do exactly that, just open source.
Is the adoption of these libraries, is there 1 or 2 that have the majority of the adoption, or is it spread across? Are they all the same? Like, are some newer than others?
It is widely spread out. A lot of customers, for example, if you want to do things like Monte Carlo analysis, you stay within Ray Core. But if you're doing training, then you're going to work with Train and Tune, maybe data. But the gaming industry, for example, or the AV and robotics industry, they work with RLib, which is reinforcement learning. So it's spread out and it's dependent on use case. And that's where the value is. A lot of our customers actually have multiple use cases. And the breadth of Ray and why our marketing folks call it the AI platform is because regardless of your use case, whether it's working with data, training, serving, or even fine-tuning GenAI and so on, you could use Ray and its constructs. So it's that breadth. Does that answer the question?
Yeah.
Yeah.
I think Ray data is a really interesting one, specifically for financial institutions, because they're trying to figure out a way to process unstructured data and feed it into their models, and they're able to do that with Ray data in a way that they couldn't before.
So that's the developer side. And it's the developers who love Ray that actually get to use it in all of those use cases and spaces and what makes it really popular. So what does Ray look like from an architect's perspective, though? So if I'm not, living in code and doing machine learning training, how do I look at it from that perspective? And I'm going to answer this twice. First, from within Ray, the architecture of a Ray cluster. And then later, after Stephen goes, I'll talk about it in the context of AWS and how that manifests in AWS. So here's the cluster architecture. It is common sense. It's a simplified structure. And I wanted to highlight some of the components. As you can imagine, there is a centralized, if you like, control plane. And that's what we in Ray is referred to as the head node. And what the head node holds is, something called the global control store, which is a centralized environment that is aware of where all the objects, data objects are across the cluster. Data objects could be, variables. Like I was storing in the Pi example, I was storing the number of trials. That's somewhere in the cluster, and the head node is aware of that. If there's a model, it's aware of that. It's also aware of all the other workers and so on. And then you have worker nodes. And what worker nodes are basically a combination of a few objects. Each worker node holds some of the objects serialized within them. So it's aware of, again, all these objects, and that facilitates communication. And then you have a bunch of workers that are typically containers that are going to receive those parallel tasks, execute them while accessing the object store and returning them back. And to facilitate all of this what is a scheduler for Ray. It is what's deciding which tasks run where, how to order them, in which order they should flow. Head nodes, worker nodes, and their components are containers or VMs. They're going to run in either EC2 or containers within EKS. And this architecture just builds out. And then you take those constructs I showed you, and Ray takes care of the scheduling and the bringing back of results. And once you set up a Ray cluster for a developer, they're now in control about what happens across the cluster, how things are parallelized. A lot of times they let it run with default scheduling, and then they have the ability to then tweak it, allocate resources, number of CPUs, GPUs, etc. Now, this architecture lends itself to be not necessarily tightly coupled with the underlying hardware. So you could have some worker nodes that are CPU based, some that are GPU based, and you can have a heterogeneous cluster that distributes and is aware of that compute and distributes things accordingly. And that's great because if you are doing a machine learning model and a lot of the training is demanding on those GPUs, the last thing you'd want is to do data processing on those GPUs. That's a total waste, or at least those GPU nodes. You want to keep those GPUs busy. So with a heterogeneous cluster, Ray's going to take the data processing and do it on the CPU-based machines, and then feed that over to the GPUs in a streaming fashion. And so you get better utilization, which brings costs down. And so this architecture lends itself to that. Questions?
It looks familiar to Kubernetes. Can you maybe talk about the similarities, differences, intersection?
Absolutely. So within Kubernetes, the building block is what is called a pod, which is a collection of one or more containers. We know that, right? And then you can do whatever you want within them. In Ray, the blocks that are running are either tasks, like the task that I run and parallelize, or they are actors. Those are tasks with state. They keep an idea of their internal state. And so they're a lot higher level as abstractions. And to a developer, those look like functions and classes. And that's the difference. And that's why it's a little closer to how a Python developer thinks and works. And just so happens that the majority of the AI industry is Python developers, right? And that's how I would look at the difference.
That's helpful.
So what that lends itself to as well is now you can have both. So there is a certain level of magic of having Ray on EC2, but you can also have Ray work on top of a Kubernetes infrastructure, such as an EKS, or even if a customer would prefer on their on-premise Kubernetes cluster. Let's talk a little bit about that in a little bit. Actually,
Now, any other question?
Yeah, just a quick question. If you look at Ray as an accelerator and a utilization, improver mechanism, what has been the impact of DeepSeek?
So DeepSeek as a foundational model that's open.
As as in basically itself requiring less power to achieve the same level of output. Like I'm talking about the DeepSeek thing that came up.
Right. So the DeepSeek model is interesting because, first of all, it validates the notion of openness in the ecosystem, and Anyscale is built around the idea of open source and so on. But second of all, whether it's DeepSeek or any of the other open foundation models, the technical approach that we take is a lot of these models remain bigger than what would fit typically in a single node or a single GPU, and you need to distribute them just to serve them. And that's why we have a library erase serve that works with other libraries that actually facilitate doing that in parallel. How do you manage that? How do you have multiple versions of this model running in parallel to serve at large scale? And with Ray, again, you have a function, use a framework like Fast API or whatever Python framework for web development, and then you add a wrapper, it's a Ray serve, and you go from there. So the direction of going towards open foundation models and then becoming more persuasive is something that Ray is going to continue to support. Does that answer the question? Okay.
And DeepSeek released their open source code as well in terms of what the small part, for example, the framework they built out on GitHub, underlying power is Ray. So they use Ray core to build out the high level abstractions and they build out the.
And happy to take more GenAI questions as we go. All right, so it turns out I was planning to talk about Kubernetes and Ray right away. So how do you get Ray running? You could spin up your VMs and run Ray head node and a few worker nodes, and you have a Ray cluster. Or you could use the open source operator that's part of Ray called KubeRay. This is an operator that you install on top of Kubernetes. And now the same way you can create a pod or a deployment in Kubernetes, you can actually write a YAML file to deploy a Ray cluster. And then kubectl will apply that YAML file, and you have a Ray cluster spun up on top of Kubernetes. And if you configure your cluster to be elastic, it'll talk to Kubernetes and grow and auto-scale the underlying compute. And KubeRay is the way to do that. It is open source. It's a Helm chart that you install, and you're good to go to deploy Ray clusters. And this is, from my experience, the preferred way for teams that choose to do self-managed Ray. They prefer doing that on top of Kubernetes as opposed to managing VMs themselves. All right. Any other questions or comments about Ray itself?
Yeah, you can be integrated with the Airflow, right, for orchestration.
Great question. Yes.
Can you repeat
But you're
it just a little
bigger
louder?
than.
Yeah, the question is, can Ray integrate
Right.
with Airflow?
Yeah.
Ray made a conscious decision
Right.
after dabbling with workflows and so on to step back and actually work with the ecosystem. So a common use case is putting a Ray job or a Ray task in the context of a workflow of jobs. And so you could use something like Apache Airflow or a managed Airflow service to actually launch one or more Ray jobs across the board. And that is commonly, for example, you could do some data pre-processing in parallel. You can then do some branching workflows and so on, and Airflow work well with that, even within the Kubernetes environment. It's a common use case, it's a common ask, and we took the opinion that we will not grow Ray into workflow manager to work with the ecosystem.
Thank you.
All right, so that's the first part. I tried not to mention Anyscale at all in the past half hour because I just wanted the focus to be open source Ray. But now that I covered that, what we want to talk about next is, like I said, one way you can think of is Anyscale is to Ray as EKS is to Kubernetes. It's a managed service. So what my colleague is going to do next is walk you through Anyscale, the platform, and what that managed service is and some of the features that come with it that customers can avoid doing by using the Anyscale platform. Stephen, are you on?
Hello, everyone. Are you able
I think we
to?
need to unmute him somehow.
Okay, he's on the call, and feel free to grab the screen and share.
Can you hear me?
Stephen, we can't hear you somehow.
You can't hear me?
And okay, so
Oh, now we can.
Okay, can you hear
Is
me
his
now?
last name actually Papa?
Yeah.
hold on.
That's ridiculous. It's amazing.
Let's see if we can get the volume up here. Stephen, can you hear us?
I can hear you, yes.
And we can hear you.
Okay, good.
Feel free to share your screen and take it away.
Okay, thank you.
Let's go.
Can everyone see my screen?
Yep, sir.
Okay. So Omar just went over what the open source Ray framework does. So basically, it's about taking your single node Python code and how to distribute this over. But as mentioned, this is similar to the relationship between EKS and with open source Kubernetes. So if you're using the open source version of it, this can get you to a development phase quite quickly. You have an ease of development. You can get to a moderate scale for an application, but then it needs that existing infrastructure set up. There's a lot of do it yourself, and it's usually tied into a single cloud or an on-prem setup. So very similar to what you see with customers that are coming over to EKS. What Anyscale helps to do is help get that to production faster. So whereas Ray can have an ease of development, this can also give you an ease of deployment and also increase developer productivity, larger scalability capabilities, and then also takes care of that underlying infrastructure. So we can tap into people's existing EC2 or EKS, and then everything is going to be as out of the box managed solutions. And we also provide a multi-cloud and also connect into an on-prem setups. So what are the advantages that we kind of see? We have the performance and cost efficiency. We mentioned earlier about the Ray Turbo library, which has those optimizations not available in open source. We also have enhanced infrastructure. So we're going to go over an example where we'll try to do this live, where we're going to spin up 100 nodes in EC2 in under a minute, not even using warm pools, but using that enhanced infrastructure to distributively call EC2 instances and attach them to the cluster. We can also support things like handling Spot for elastic training and other workloads you don't typically use Spot for. Better auto scaling capabilities, so we can actually scale to hundreds, if not 1,000, like GPUs in a minute or two if needed for things like model services. and then those proprietary optimizations. There's also enhanced reliability for better observability, fault tolerance, and then also like one of the biggest things I've seen to help those customers de-risk their applications would be that enterprise-grade support and training that we provide. And then we're going to go through some of those developer tooling that's part of the platform. One thing we're going to be touching on, and I'm sure we'll have lots of questions about later, is how is Anyscale actually deployed? So this is very similar to a Databricks deployment. So you have the control plane and a data plane architecture, except that we also offer on-prem solutions. So we have our control plane residing in our own AWS account. We're going to be going into more detail about this later. But then it is able to connect through either a like EC2 or direct to VM offering. We can also do on-prem bursting into AWS, and then we can also deploy anywhere that has a Kubernetes operator. So this can include the standard 3 top cloud providers, but we also have solutions for secondary cloud providers and connecting those to AWS if needed. For comparing what you would use Ray and Anyscale for things like what do you get with the open source versus what you get with Anyscale. So with Ray, it really is just about like the open source just cares about the distribution of the application and managing that distributed application. However, with Anyscale, we provide the ability of cluster management, that hybrid combination that we see. You especially see this a lot in financial services where they might have more like GPU requirements happen on-prem, and then they want to be utilizing the cloud for various different sections, or they have to do multi-cloud for legal reasons. And then we can also help with those GPU optimizations through our enterprise support for optimizing the Ray applications, as well as providing those best practices for integrations with NVIDIA libraries, as well as managed model serving. The best way I can kind of describe this is through an example of, say you're an open source developer and you are trying to do a model serving application. You're using our Ray Serve library for doing this. If you're doing this on top of your own infrastructure, you are the one that has to set up the infra. You're the one that has to set up the networking, and then you have to be managing that auto scaling for volume burst. You have to manage all of the how that network is configured. Whereas if you were to deploy that on top of Anyscale, it is just say, go deploy this service and to set up all of that underneath the hood. I wrote a blog a couple of weeks ago, kind of related to that question we just had about DeepSeek, about how does a developer go from like initial login to deploy in DeepSeek within 5 minutes, and how easy that is for them to go from like just starting to then having something that can scale up to thousands of GPUs if they need to, and it's already set up with all of the networking capability to handle things like traffic bursts. So how do we also de-risk this from an enterprise perspective? We provide the support for the underlying infrastructure, managing the platform for their developers, as well as that optimization support. As you can imagine, Anyscale customers have a higher priority for things like questions about Ray, or especially Ray feature requests. So we also provide access to our engineering team. And then we're also one of the largest contributors to VLM. So a lot of model serving solutions out there are more like they've taken open source VLM and they put it on top of Kubernetes, and then they put a black box around it. You might notice with the things that we're going to be showing today, we do not like black box solutions. We like open systems that we can then give the developer complete control over. As an example, we ran a case study with a customer where comparing our serving with OpenAI, just because we had the ability to give them an open system, we were able to show that we could save them, $12.5 million for that exact same workload, because we had all of these optimizations and we were at this cutting edge of model serving that we can then give them access to all of those optimizations and all those configurations. So this is what we mean by VLM engineering support, but also by open systems. We expose all of these to the end customer so they can customize it. When you compare it to how, oh, go ahead.
Okay.
Sorry, so you guys say de-risk a lot. Is that just reducing the risk of over provisioning? Or what is the risk that's being reduced?
Well, when you look at a lot of enterprises when they're doing their different large-scale AI pipelines, a very small percentage of those actually get into production, even when they have working pilots. And so a lot, when we mean by de-risk, is not only reduce the overall cost of ownership of maintaining or developing that one, but also just making it so that the data scientists and the data engineers can really just focus on that particular area, not having to really care or worry about these other parts of it. So the scalability of those pipelines, like they can write something that works on their laptop, and then when they come over to Anyscale, that same code, they can deploy this across hundreds of terabytes or petabytes of data, or some of the largest ML. I think one important thing to also mention is that we're not just about giant foundational model training. It's not a niche AI platform. We're actually one of the very few ones that are able to do it from like improving the performance of a single node training script. You could do multi-threading using Ray, or you could do this over millions of threads. So it could be everything from traditional ML, deep learning, reinforcement learning to the largest Gen AI. But going back to your original question, for de-risking it, it's more about like ensuring that they can get to production and stay in production longer than if they were to doing this as a self-managed way.
Got it, thanks.
A lot of times when we compare this across like legacy systems, so there's a lot of AI and data platforms, as you know. So what is the difference between Anyscale as a platform and our approach? As mentioned, most other platforms will specialize in a type of AI. And what we do is we'll just work on a broad ecosystem integration and improvement of all types of AI. So you can come to us with like a scikit-learn model, XGBoost, but you could also come to us with a multimodal video generation model, and we'd be able to scale that out or improve it. We don't believe in closed systems. We want everything to be open systems. A lot of other AI platforms are focused around structured data only. So I came from Databricks. This was structured data only, pretty much. And what we wanted to bring is like, now you're able to process all types of data. The way I can describe this is that if you can express your data operations with SQL, then this is usually where you'd stay, like with a data warehousing solution. However, if it is easier to express your data logic with Python, this is where you would be able to come to Anyscale, and we're able to scale out that code in a much better fashion than anyone else can. We do not lock in your data, and we do not lock in your models. So there's not that type of vendor lock-in. We work with all types of data formats. So we work with not only all types of unstructured data, but for structured data, we can work with all types of lakehouse formats, any types of the standard Parquet CSV at very large scale. Whenever we test out any of our training or of our data processing, this is at the terabytes to tens of terabytes or petabyte scales. And then we are cloud or also on-prem, so we can be deployed anywhere that has a connection to the control plane. Before I go on to actually show what the platform is, are there any other questions? Okay. So we're going to spend, I think, probably just the next half hour just kind of going over some of the what exactly is this platform, how does it live up to what we just described it, and then always feel free to interrupt, because I cannot really see the room right now we're presenting. Just feel free to interrupt over, and I don't think I can see the chat either. So if anyone's asking questions in the chat, please let me know. So the overall Anyscale platform itself, it has a pretty simple UI, but there's a lot of powerful infrastructure features built into it. So as mentioned before, open source Ray does not give you that infrastructure capabilities. It has to tap into something like Kubernetes or Slurm for the open source version of it, or through like bash scripting to get this connected across different VMs. And that part can be difficult to maintain. So we're going to go through just a basic example. So a workspace in the Anyscale platform is more of like think of it more like a resource group for all of the parts that a developer would want to use. And we want to be using all the developers' favorite tooling. We don't like proprietary notebooks or libraries. We prefer to be using like VS Code or Docker or all of these things that developers want to be using. So I'll create a new workspace. We have a base container images. So this can be where you can just use these prepackaged container images, or you are able to build your own or use external images as well. And then we kind of patch in that the Ray to replace it with our optimized version. So I'm just going to use the Anyscale base image. Now, the part that I wanted to mention about why this is like a lot more powerful than other data platforms that I've worked with before is going to be the scalability, but also the flexibility of it. So when you look at the what we're going to be doing for worker nodes, you can either do an auto select nodes, which this is where it's going to be looking at the application and attaching the appropriate instances as it during runtime. Because of our fast scaling, as in like these nodes can be attached in a matter of seconds and not minutes, this means that from the developer experience, they don't really have to even care about what instances are being attached. Now, this is for the development phase when you're building out those applications, not actually for production. So if I did auto select nodes, it would be able to automatically attach different types of instances during runtime. But for today, let's instead add our own instances. So we can do CPU only, as well as many other types of GPUs, but we can also do GPUs alternatives. So if you have customers that want to be using Trainium or Inferentia, we are able to connect them to these clusters, as well as integrations. We've worked with AWS to integrate Trainium with some of our high-level Ray libraries. And then also if I had a workload, say you were doing a training job where you had a lot of data pre-processing, and then it's being fed into the model. Usually what happens is you have to split this up into multiple subtasks and then persist the data in the middle. In this case, we can actually keep it all in memory, because what we can do is have very good auto scaling for heterogeneous compute. So if I had that, I could say my auto scaling, like maybe I'm doing auto scaling for CPUs, and then I also do auto scaling for like GPUs. And that means that when the CPUs are needed for the pre-processing, it can scale up. And then we can also auto scale down to 0 for the GPUs. And then it could be able to, after it's done pre-processing, auto scale the CPUs back down and then just keep the GPU nodes. So this means it's able to reduce the overall time as well as the storage requirements, because it can keep it all in memory while it's reducing the GPU idle time. But for today, I want to show the fast scaling for it. So let's go to, let's just do 100 nodes. This is from EC2, and I can also say I'm going to scale with on-demand, spots, or spot first, fall back to on-demand, but today I'll just do on-demand. So this will be spinning up 100 nodes direct from EC2. While this is doing this, I want to show where that compute is coming from. So we have a concept of the Anyscale cloud, which is not really going to be as much of like it's not saying a different cloud provider. What it is saying where that compute is coming from and which region that is coming from. And this can be from across multiple clouds. It could also be on-prem. So right now I'm in US West 2. I can switch to East 2, but now I can also switch over to EKS. And from the perspective of the developer, to switch between these different environments, the only thing that changes is this cloud ID they would reference in their infrastructure. So they can use that same tooling across EC2 and EKS, but they can also use it for things like, now I've moved over to my on-prem setup. So this is actually going to just AWS connecting to an existing on-prem cluster. Now I can also switch over to GCP. So for those customers that need to have multi-cloud, this is very appealing to them, because now they don't have to maintain 2 different tooling stacks across multiple cloud providers. And we also provide a serverless offering. for where those VMs are going to be coming from Anyscale's own AWS account. Let me go back over. While I'm waiting for the workspace to spin up, which actually I accidentally did a better a better demo than had intended. I accidentally spun up 100 T4s instead of 100 CPU only nodes, but it was still able to complete this from with under a minute. So if I look at the logs, I requested this at 10:17. Let's see. So it only took 1 minute and 30 seconds, so a little bit longer than usual, just because I was requesting GPUs. But this is direct from EC2. These were not pre-warmed. This was where we have our own infrastructure to distributively call the AWS commands to attach these. So I've upscaled to 768 CPUs. So let me go over to
And
what the
Stephen, while you're
developers.
doing that, I just want to drive a point home. So if you think of this from the perspective of the developer now, they've developed an algorithm to do some training, and they ran it on their MacBook for a couple of epochs. They're happy with it. Now they want to do scale. This is how they get to that.
Yeah.
The same code, just tweak a parameter for parallelization, and it ships and it parallelizes across 100 GPUs, 200 GPUs, however many. It's the same code, right?
So is it basically optimizing for scale and speed only, or is it also optimizing for cost? It looks like it's a manual adjustment for cost.
Right. So the question, Stephen, and maybe you can take it, I can take it.
Mhm.
So are we here with Anyscale and Ray optimizing for just scale and performance, or are we also optimizing for cost? Stephen,
When
I
you're
can go
getting
first.
the work done.
yeah.
When
Yeah,
you're getting the work.
Oh, go ahead.
Oh, I was saying just for getting the same work done, optimize for cost also.
So we are not a hardware provider. So for actual cost optimization, we look at optimizing the performance and the scalability. So two different aspects of it. For utilization, we typically see customers coming to us with less than 60% utilization of their cluster. And then after the migration, we can usually get that to above 85 to over 95% utilization, just because now there's a lot more functionality at their disposal that there was not before. We'll go into that in more detail of some of those libraries. And I realized I misspoke earlier. If you noticed my screen, it was actually I created it was one T4 and then also the 100 CPUs. So that's created a heterogeneous one instead of 100 GPUs. But when you look at the how to optimize for cost, you can in this case from us, since we're not actually billing them for the VMs, this is going to be for giving them the ability to run on whichever hardware they want, the ability to get better utilization and better scalability, and then for the better speed. Now, speed can be a bit tricky because if you're using something like Ray Core, you are distributing anything in Python. The addressable market of Ray is anything in Python at this point. So we don't have as much control over generic Python functions. We give them the ability to improve the performance through distribution. Now, if they're going to be talking about higher level libraries, that's where we can get better speed. So for instance, if I was using Ray Data, I can get 160% faster for the same operations with Parquet than I can with Spark, and therefore I decrease my VM cost. Does that answer your question?
Yes.
I think I have a related question. I think, Stephen, you made a point earlier on in-memory. Can you talk if at all, that impacts the customer's overall data storage approach? Or is that, it might not even be a valid question.
So the example that I gave was a common situation I see with distributed training, where you have to persist the data in between because you have a CPU pre-processing, and then also with the like then it gets moved over to the GPU only task. Now, that's a pretty small amount of data compared to the overall pipeline. So from an AWS perspective, I would actually be more excited about the ability for like increase the amount of data available, because now you're able to process much, much more raw data. When I talk to customers and enterprises, I often hear it, I have 10 times as much unstructured data as I have structured data, but I can't process it. It's just sitting there. Now with using Ray and Anyscale, you're able to process this data that you can't do with conventional SQL engines like like Snowflake or Spark, or like they can't easily process or read that sort of thing. So like it helps to optimize the storage for things like AI workloads where we're kind of doing hacks because we can't have heterogeneous compute, or we can't efficiently do this with traditional tooling. But from a perspective of like an AWS perspective, it increases the addressable market of what we can now process in efficient ways, and that can lead to like much more data being available for your customers. Does that answer your question?
Yeah, got it. Thanks, Steve.
Was there any other questions, or should we look at the developer tooling?
Go ahead. No questions in the room.
So right now, this is like what a user would see for when they are developing their applications. They have in-browser VS Code, in-browser Jupyter Lab, and Terminal. Again, we prefer open systems, and we prefer to use what developers want to instead of forcing them to use like our own type of tooling. We can also connect to desktop VS Code, or through Cursor, you can also connect through like PyCharm and all these other IDEs for whichever they'd like to. They can then terminal into the cluster as well, and then we provide things such as Grafana metrics. So right now this cluster is nothing's running, so the metrics will be empty, but we'll give a second to kind of see the experience. And then we also have specialized dashboards for like different applications. So Ray Core, data dashboards for model training, for model serving deployments. And then all of these ones have more specialized metrics as well. And all of these can be exported to things like CloudWatch or Datadogs. For logging, we have enhanced observability and logging compared to open source. We also have debugging capabilities. So we have a distributed debugger. So that if you have, for instance, if you have a error on, say, worker node 1000, I don't have to read through 1000 logs to find it. I can just go and grab that error from that specific, and the stack trace from that specific worker without having to look through an enormous stack of logs. So this is very common for for other distributed frameworks, and a large pain for their development process. We have our own Ray dashboard. So this allows you to have a better debugging capabilities by being able to look at individual jobs running, as well as different metrics about the Ray cluster itself. So this is where we can monitor for things like overall memory usage by different nodes, or overall cluster metrics, or this concept of actors, which I don't think we got into. We saw like with Ray Core, you have distributed tasks, which is like a distributed function, but we also have a distributed class. So this is like a distributed Python class. So it's a stateful distributed actor. And this allows us to like really be able to take any Python script and be able to migrate that over to Ray Core. So you can kind of think of Ray Core as a framework for building distributed frameworks. And this is what we mean by actors. And then also for managing dependencies, going back, this is where we use Docker, pip, as well as being able to just set environment variables. So it has a pretty simple UI, but there's a lot of small things packed into it. So for example, once I'm done with development, I can build an optimized image. This is where I take all of my dependencies, and then I'll cache them and put the files in such a way that when it's being run as a model, like a model service or a deployment, it's able to distributively read that container or things like the model weights in a much faster way. This is why we're able to get to scaling speeds much faster than Kubernetes, because we're able to do things like load the model or load the container image in a very fast way. So this is a blank example. I want to also showcase like what those libraries look like for those end users. Of what exactly would they be looking at for when they come from single node over to migrating these over to Anyscale. But before that, do we have any other platform questions? Yep. Let's see. So we kind of briefly went over some of these ones, but I think it was really important to kind of showcase the approach and why Ray is and how that relates to how Ray has become so popular. So when you look at what users are doing for all types of AI applications, it's always going to be some format of we need to do data processing, we need to train the model, maybe we need to tune that model a bit, and then we need to be deploying this. And our approach that we have taken is to, instead of creating like a hyper optimized like niche framework, we have instead said we're going to play with the rest of the entire ecosystem and have it enhance all of these other frameworks. I kind of think of this as like the hardware wars back in 2019. I was at Intel AI at the time, and we were competing against NVIDIA. And at that point, we had all of our own like hyper accelerators for particular type of computer vision deep learning tasks. So it was like, oh, we can do, we can do ResNet 50 this much faster. But it didn't really matter that much in the long term, because at the end of the day, GPUs eventually won that race because of how it was able to work with the rest of the ecosystem and had that strong community around it, and was also general purpose. And this is kind of one of the reasons why we've seen that really large Ray adoption, is because we're able to have that strong community and that integration with all of these other frameworks. When Ray first came out, it was actually meant for reinforcement learning, and then moved into computer vision, and then it went into Gen AI. So as the AI ecosystem has evolved because of this approach, the users have been able to feel comfortable that it's going to be future proof and that it's able to integrate with all these different tasks that they want to. They don't really, and they don't even have to really wait for us to come out with a lot of these integrations. It's actually easy enough for them to build things like custom data connectors, or how do we integrate these different libraries with customized tools. That has been our kind of approach and philosophy for these AI libraries. Let me go through. So with Ray Data, so this is very similar to, it has a pretty similar feel to a lot of other frameworks like Pandas or PySpark, except the way that this works is like, it's a very general purpose Python data processing framework. And it's built all on top of essentially a distributed set of Apache Arrow tables. And because of that integration with Apache Arrow and the wide adoption of it, it can integrate with many other types of data types and libraries. So in this case, what we're doing is we're reading in a Parquet data set, and then we will be passing that data set. But an important thing about what this is doing underneath the hood is that it treats this as a streaming data set. Even though we're not doing data streaming in like the Kafka way, we're treating this more as a distributed model streaming set. And this is why I have seen a huge scalability in comparison to even like I've made hundreds of pipelines at Databricks with Spark. And I'll say that Ray Data is far more scalable for doing data processing than even these other large scale frameworks, because of this ability to have streaming execution. So what it does is it will bring in chunks of the data, and then you can map different Python functions on top of this. So the user can bring kind of like a UDF, but then you could also do like more complicated, so like stateful UDFs on top of the data. So this is what we'd be using for pre-processing. We're using a really basic example in this case, but you can do this up to the petabyte scales without actually needing a cluster that has like a petabyte of memory.
And Stephen, I'd like to add some color to the architects in the room. So when I was an architect at AWS, I came from an infrastructure background. This was foreign to me. But what Stephen is describing is how a machine learning engineer, sees data as some Python code and reads the data set. And in their mind, they're thinking in Python. But what this translates to is maybe a petabyte of data on S3. So this read Parquet one line of code is going to be reading a petabyte of data of S3. And the developer doesn't need to think of that because of Ray. Now, if you're going to load a petabyte into all those GPUs, you're not going to do it all at once. You're going to take it block at a time in chunks. And so there's a lot of planning that goes into loading a petabyte through one epoch of GPU training while the GPU is at 100%, and bridging the gap between that cloud infrastructure and how the machine learning engineer developer is that great. So those two lines of code are doing a lot of magic and the heavy lifting for the developer.
Yeah. In this case, it's a pretty small Parquet, but yes, as Omar just mentioned, you can do this to pretty much any type of scale that you need to. This can be used for training your smaller models, but if you need to use that same sort of method for either doing large scale data processing, or if you're doing large scale model training, all this is doing is creating that distributed set of chunks of data and kind of streaming that through whatever process that the user has defined. And Omar is very right. Like the modern day data scientists and data engineers, they're using Python much more. Like they're moving more towards Python than they are from like Scala or even SQL. But the problem is all of these other frameworks that you use for doing your data ETL or your data processing, they were not made for Python. And so this gives the user a much easier way to process their data in Python that feels very familiar and easy to use for them in comparison to other frameworks. We'll kind of go into more of Ray data later. But in this example, like I can then push this into an XGBoost trainer and just do trainer.fit. And so we can also start layering different frameworks on top of each other. You might notice that was actually a different library I just mentioned. That is the Ray train framework. But we've built all of these ones to also integrate with each other. So you can use Ray data for doing all of your data pre-processing and loading that into Ray train, but you can also use things like Ray tune to then do hyperparameter tuning. Ray tune is actually very popular amongst enterprises. I've seen it be about 2x the performance of HyperOpt in my experience. And so if you have customers that are doing like XGBoost training and they're trying to do hyper optimization of it, so very common use case with XGBoost or other tree-based algorithms. I see this a lot in the different financial industries. I've worked with a lot of the different banks. This is, I think, one of the most common approaches is actually what we have on the screen for like, what do I see with like how do we go from that single node XGBoost to a more efficient distributed XGBoost? And the same can be said for small scale PyTorch. It's kind of a thing that I see with a lot of financial services where they have a lot of legacy code that's been built for single node, but now they want to scale it up to more and more data. And this is where that approach can help them.
Right. And Stephen, again, more color to the team. So that line of code before was about streaming a lot of data. This one here was about using the Ray tune library to run potentially hundreds of training jobs to optimize hyperparameters. And again, for the machine learning engineers, just a few lines of code that gives you a lot of power. Stephen, just reading the room, one of the things I want to do, I think conscious of time, is to transition to the next one. What would you say are the highlights of what you want to show us next?
So I think on my side, probably because I also work on our Ray data team, one thing I really just wanted to highlight for is like with the financial services, I've mentioned before about, and I heard that Hank had mentioned before as well. So one of the biggest opportunities that we have seen, especially with the financial services, has been about like being able to take all of that data processing that was previously unavailable to them. And now when they come over to Anyscale, they are able to read in like what I mentioned before, that 10x amount of unstructured data that's just sitting there, and being able to bring that and either like ingest that and move it into structured, or ingest that and being able to train their AI models on top of it. So I think that's one of the biggest promising things I've seen for future use cases. For past use cases, it's about taking that type of legacy single node scripts that financial groups just have so many of, and being able to then distribute them. So this might be like if you have customers that have like, I have a forecast model and I want to distribute this, but I can't, or it's very inefficient. This is where you can use these tools like Raycore or Ray Data, and you're able to distribute these legacy scripts across massive data sets in a much more scalable and efficient manner. For the platform itself, I just wanted to, like, the main points I wanted to get across was just how this has all of the other parts about what is needed to get things into production that open source does not. So we didn't get to this yet, but we also have, like, once you move from a workspace and you are finish your development, you either submit this as an Anyscale job. So we have ad hoc or job queues or job schedules, or as an Anyscale service, which basically allows you to just put any type of Python code. It could be model inference, it could be function serving, behind a highly scalable API service, and it could be done very quickly. And this is that point that we really want to get across, is just how, like, if you have customers that have large scale Python teams, like, we don't want them to have to be distributed experts. We want, like, that most teams don't have distributed engineering experts. They can have architects that help them with their infrastructure, but we really want to be, like, making it easier for these teams to get things to the scale and production that is needed for those future applications. Let's see. Are there any other questions, or should we move on to any other sections of the platform, or should I hand them back over to you, Omar?
I think maybe this is good just for you to summarize. I believe that,
Yeah.
Stephen, I think this is super, super helpful. Maybe Omar can.
Yeah, let me see if I can sort of bring it home now as we move forward. Thank you, Stephen. So,
Thank you.
So what's the message so far? So we showed you two phases. We showed you open source Ray. That's when I was speaking. And chances are a large number of your customers are using Ray to do distributed computing. They're using it for machine learning, data processing, and some other distributed computations. Okay. And they're probably doing that on top of AWS, whether it was EC2 or ETS. And so these are workloads that you can optimize and work with your customers to grow them. That's one thing we showed you. The second thing we showed you is how Anyscale is the managed service that can help your customers take away that undifferentiated heavy lifting. The same way you position EKS, Anyscale can do that for Ray deployments, because otherwise your customers are doing it themselves, probably hiring teams. So they're making decisions, say, do I hire a team to deal with the complexity of Ray and Jupyter and VS Code and workstations and so on, or do I have, get a managed service? So as we look at both of those things, I want to bring it home and sort of talk about how Anyscale would work with AWS. What this diagram shows is an architecture view of what Stephen showed you. On the left-hand side, you have the control plane. Stephen was working with the UI that has these concepts of jobs and workspaces and services. That's what we call the control plane. But what that launches is either Kubernetes or EC2 instances in your customer's AWS environment with GPUs and so on. And so your customers can continue to do everything within their AWS accounts, only they don't need to manage that infrastructure and get a better user interface. So that's one. And it really boils down to this, right? You can read this diagram probably much faster than I can. Give you guys a minute. But essentially, to get started, what your customer builds is a VPC in an account and then gives access through a cross-account role that would assume an IAM role that then is able to spin up EC2 instances and memory DB, EFS, and so on automatically. And so when, like Stephen, your customer is using the UI or the API to create things, it's just creating this in the environment. Now we have Terraform scripts that deploy this, but we also have guidance if the customer wants to build their own environment or integrate it. So, whether it's their networking or their policies and so on, it's just at the end of the day, AWS with permission to spin up machines, tear them down, and so on. This is what it eventually boils down to. So you're then helping your customers do management of this environment for cost optimization, performance, and so on. The other alternative is to do the same thing on EKS. And this is actually another way to do that. If your customer is invested in the Kubernetes ecosystem, there's a Helm chart they install, and it deploys an Anyscale operator. So you have an operator running within Kubernetes. It phones home to the Anyscale control plane for instructions. What do I do? What do I do? And if the instruction says spin up a new Ray cluster, it goes ahead and deploys pods on EKS. So that's the second option. And something that's getting a lot of buzz in the market, it's almost every other customer is asking for it today, is how do you work with HyperPod?
I was going to ask you.
Now, there's a bit of a curveball there. The control plane can do two things on AWS, our control plane. It's either calls the EC2 API, spin up EC2 instances, or works with Kubernetes. I think previously HyperPod had its own APIs within SageMaker, so we don't work with that. So what we tell our customers is, sure, now that you can have an EKS cluster backed by a HyperPod, just deploy your Kubernetes operator, and you get access to the full power of the Anyscale platform on top of that. Customers love this because it means that their investment in HyperPod can be maximized, the utilization and so on, by bringing Ray to it and our Ray Turbo.
And we have a few customer example as well, which has been kind of not in a public case study yet, but
Right.
they are very successful using HyperPod and Anyscale.
So that's it. Just to summarize, developers love Ray because it gives them power to do things in parallel across AI and ML. It feels like a platform to them because they can go from code on their laptop to the scale that they need in an optimal way. And Anyscale makes it really easy to manage Ray, remove that undifferentiated heavy lifting, and it all eventually boils down to compute on AWS. I'll take any last questions. I know possibly that I'm between you all and lunch, so I'm mindful of that. But happy to take any questions, either directly right now or after we close.
Okay.
All right. Well, thank you all for being a great audience. I appreciate all the questions.
Thank you so much for being here. So it is lunchtime. We're taking a break until 2. We're not providing lunch, but there is so many good places to eat around here. Feel free to go, but you will need to be escorted out and back in. I know. And then on the 16th floor, there's a cafe that has lunch as well, and a beautiful, balcony that you can go outside, which is nice. I don't know what's beautiful or not. I don't know why I said that, but I saw it and I was like, oh, this is nice. At any rate, so please feel free to do that. And then for the H2O folks, if you stick around a little bit, I want to chat with you about the interview we're doing. All right.
It's at 2 p.m., right?
At 2.
2. How many Amazon escorts are there?
Good question.
1, 2.
Now the front desk knows you, right? So if you're going out and coming back in, Yeah, just give them your badge and they'll hold it for you until you come back. It's not like
Oh,
you
so
have
we
to
should
re-badge.
probably bring our stuff
Um,
in case. Okay, just stop.
the recording's, yes.
Perfect.